Hi, in this video, I will be showing you problem number 28 of chapter 14, section 1. Sketch the graph of the function f of xy equal to 2 minus x square minus y square. So first, f of xy, usually written as z equal to f of xy, is a surface, which is a three-dimensional surface. So in order to sketch the graph of this, what we need to do is to get different traces. What it means is, if you take a cross section in the xy plane, or a plane, horizontal plane, or z equal to constant plane, what is the trace? What will be the cross section? What is the curve of intersection? Then if you take a cross section on a plane, which is a vertical plane, which is parallel to xz plane, what is its curve of intersection? Similarly, in the vertical plane, y equal to constant or x equal to constant, which is a plane parallel to yz plane, what is the cross section? Or in other words, what is the curve of intersection of the surface with that plane? So if you get the xy trace, xz trace, and the yz trace, and then we can get an idea of the surface. So that is our goal here. Get different traces. Z equal to f of xy, which is 2 minus x square minus y square, which is given. So first let's find out xy trace by setting z equal to 0. So 2 minus x square minus y square equal to 0, or 2 equal to x square plus y square, which is a circle with center at the origin and radius square root of 2. Okay, so this is the projection of the surface on the xy plane, which happens to be a circle here. So is it the same for all horizontal planes? So z equal to 0 is one horizontal plane. So we can give various values for z equal to constant. The constant can be chosen any value. Then we can find out different traces and different horizontal traces. So we will give a value, say k equal to 2. Z equal to k equal to 2. So the equation becomes 2 minus x square minus y square equal to 2. So x square plus y square equal to 0. That means this is possible only when x equal to 0 and y equal to 0. This also tells us the point 0, 0, 2 lies on the graph, or z-intercept of the surface is 0, 0, 2. X equal to 0, y equal to 0, and z equal to 2. So that is going to be a point on the graph. So can z be ever more than 2? So let's take k to be some value which is more than 2. K cannot exceed 2. Let's check that. So let's say k equal to 3. Then 3 equal to 2 minus x square minus y square. This will become x square plus y square equal to 2 minus 3, which is negative 1. Sum of two squares cannot be equal to a negative value. This is not possible. So z equal to constant cannot exceed 2. So 0, 0, 2 is the highest point on the graph. So we will see whether it is highest or lowest. Z equal to k cannot be less than 0 as well. K can be less than 0. So all traces in z equal to k are circles, but k cannot exceed 2. So you can go all values up to k, k equal to 2 on the positive side, and all values of k, negative values of k are also okay. But k cannot exceed 2. We saw that as an example here. Now this is about the xy trace. So we can give an example and show the graph for one specific value of z equal to k. So let's take z equal to 0 case for the example, which we already said, x square plus y square equal to 2, which is a circle with center at the origin and radius 2. We graph that on the xy plane. Instead of 3-dimensional, we are making it 2-dimensional now when you take the trace. So it will be on the x, it is radical 2. On the y also, it's radical 2. It's a circle of radius radical 2 and center at the origin. So every xy trace is going to be some kind of a circle. The radius may be varying, but it's a circle. So it's a family of circles which are xy traces. Now let's find out the next one as xz trace by setting y equal to 0 in the original equation. So z equal to 2 minus x square minus 0 square, which is a downward parabola in the xz plane, where the vertex is at 0, 2. xz plane, it is a parabola, downward parabola. We can graph that xz plane, again 2-dimensional. So it's a downward parabola where the vertex is at 0, 2. Okay. This is a downward parabola on the xz plane intersecting the x-axis at 2 and negative radical 2, square root of 2 and negative square root of 2 on the x-axis. So this is called the xz trace. So we can also give another value for k on the plane, on the vertical plane, y equal to some constant. We can choose a constant value for k, specific value for k. Let's pick y equal to a vertical plane. Y equal to constant is a vertical plane. So z equal to 2 minus x square minus k square. So if you combine all the constants, you get z equal to some constant minus x square, which is again a downward parabola. So all the vertical traces or the traces on the plane y equal to k are all downward parabolas, family of downward parabolas with the vertex, vertical traces are downward parabolas. Now let's find out the xy yz trace. Similarly, we can set x equal to 0 for yz trace. So in the equation, if you substitute x equal to 0, you get z equal to 2 minus y square, which is a downward parabola on the yz plane. If we give a rough sketch of it on the yz plane, we get a downward parabola which crosses the y-axis at 2 and negative 2. Square root of 2 and negative square root of 2. When x equal to constant, different constant, all the vertical traces will end up as family of parabolas on the yz plane. Again, a downward parabola. So in summary, we can say horizontal traces z equal to constant are all circles. And the vertical traces, say y equal to constant, or y equal to constant and x equal to constant are all downward, family of downward parabolas. And z cannot be more than 2. Because it's downward parabolas in circle, so the vertex of that paraboloid has to be 0, 0, 2. So the surface is called circular paraboloid. The surface 2 minus x squared minus y squared is called a circular paraboloid because the xy trace is a circle opening downward with the vertex at 0, 0, 2. We can give a rough sketch of this graph, this surface. So we'll graph the xyz axis now. Usually the board is yz plane, and then the axis that comes out of the board is the x-axis. So we'll start off with the xy trace, which is a circle. It can be considered at any height, negative height, but only the z value, positive k value cannot exceed 2. The negative k can be any value. So all these are families of circles. And then on the yz trace, it's going to be a downward parabola. Then for the xz trace, it's going to be again a downward parabola. So the surface, which is the circular paraboloid, looks the way it is shown in this graph. So you can also see a colorful picture over here. So this is another picture taken from the 3D plot. Hope this video helps.